Hi, this is Karen O'Brien, and we're about to get started with the first lesson of the self-help kit. Now, if you haven't already done so, please go back to the setup instructions and follow the setup instructions to get your computer ready, and follow and also watch the video that helps you understand what's in the self-help kit and where the data is, etc. It'll just help you get your computer ready. Now, if you haven't already done this, go into the documentation folder for Flow2D. It's Flow2D, or sorry, C drive, users, public documents, Flow2D Pro documentation, example project QGIS tutorials, and put these tutorials in your self-help kit, or sorry, in your quick access, because we're going to be in and out of these folders. And the QGIS path management is a little clumsy, so it's easier just to have these right here. We're going to start with the step-by-step procedure, which will basically be opening up the project, setting up the project folder, creating the grid, assigning some variables to the grid, assigning the control parameters, and then doing a save and run. And that will be the end of this. There won't be any rainfall data in this run, so that final run will just be a test run to make sure that the data was exported correctly. So we'll start by step 1, opening QGIS. You will probably be using QGIS 3.18.2, and that's perfectly fine. If you're using 3.24, you will need an update for the plugin, so you might want to get with me if you don't have that updated plugin. You can import the project domain after you open it up, and then that will be ready to move on to step 3. So I'm going to go ahead and do that before I move on. Okay, so I'll just either go right here to my folder for QGIS. Whoops, I'm over on the other screen. Let me try that again. And you can get it from here, or you can come down here on your search bar. This is an even easier way to get it, and just put in QGIS and then just take the one you want. If you have more than one version installed, just take the one you want. So I'm going to open it up, and I don't need this anymore, so I'll go ahead and close it. And then what I have over here while that's loading is QGIS Lesson 1. It has all the data we need for Lesson 1, Part 1, 2, and 3. And I'm going to go ahead and open the first data, which is what it tells you to do in the next step. So I'm going to load that, and then I'm going to click OK to set up the transformation, on-the-fly transformation information. So click OK, and then you see here that I have a project domain loaded, and if you pay attention down here in the corner, you see that I have a coordinate system set to 2223. That should happen automatically if you follow the setup instructions completely. Now let's go ahead and get back here to the lessons. And so we imported that project domain. Don't worry if it doesn't look like this pretty little perfect outline. It's always a random color. Then we're going to set up our Flow2D project with this wrench tool, and you'll open that up and you'll create a geo package. That's what stores your Flow2D data. That system will help you assign the projection, and then you'll select a grid element size and click OK. So the project will be called lesson1.gpkg. You can call it anything you want. Just make sure that you just remember that name and keep that GPKG file with the rest of the data. And because you're going to go back into this multiple times, we want everything to happen right in lesson 1 for right now. Okay, let's go ahead and grab this guy right here. Sorry, it's this one right here. So here's your Flow2D toolbar. If you don't see this, go back and follow that setup video or contact me for technical support. I'm going to click, so I click the button and I'm going to click open to create the project path. And I'm going to I'm going to name my geo package lesson 1. And I'll just click save. And then I'm going to set my, oops, sorry, this is automatic. I got to choose the coordinate reference system. So it'll either be here or you can put it in here, and then you'll be able to come down to this list and select it from here. Either way, it doesn't matter. Just select one or the other, as long as it's Arizona Central, and let that finish, and then click OK. And then the last thing that it does is it loads the widget into all of your QGIS panels. When you see this, yours are probably docked right here. My dock broke, so I'm just going to close mine and open it when I need it. Okay, so the next step is to go into, we already set up our coordinate reference system. We got everything looking good. Oh, I don't think I hit that 30. I might have missed that, but that's okay. It doesn't really matter. And then the next step is step 4, to create the grid. Now, you may not have a computational domain, a perfect, shapefile for your computational domain like you do in the lesson. So I'm going to show you 2 different ways to do this. So let's just skip this for now. We'll just follow along the video. So let's just pretend that we're starting a brand new project and we don't have that lovely little polygon right there. We can create our own polygon in this layer by clicking the edit pencil, and then just use this guy right here to create a polygon. And then I'm just going to make a nice little rectangular polygon. A polygon can be any shape for the grid. Just be careful around grid element number 1, because grid element number 1 has some specific things that I'll show you that it has to, that have to happen. The polygon, or the only attribute for this polygon, is the cell size, and that's why I said it didn't matter whether or not we set that cell size to 30 before, because it's going to read it from here. I'm going to set it to 100 because I don't want this to take a long time to create this layer. And then I'm going to come over here and I'm going to click create grid. Now you can either click save over here, or you can click create grid, and it'll check that it needs to be saved and save it for you. And you can see over here that we have 7,000 cells at 100-foot cells, and our grid element number 1 is going to be, it kind of reads from the left side to the right side, but it starts like down here. This will be grid element 1. So the only real requirement for grid element number 1 is that it needs to have 2 neighbors. So I like to try to keep it to make absolute sure that it has a neighbor to the east and a neighbor to the south, and it's not dangling off the grid in any way. So that's the only thing. And if it is, if you don't like it, just come back into the layer, edit, grab this node tool, and you can make it do anything you want. So you can even, if you right click it, you can even give it exact vertices if you'd like to do that. So you have all kinds of control over this. I'm going to just discard the changes because I don't need to save it. There's nothing wrong with it, and we're going to replace it. So now if you do have an external domain like this, you have this external domain just like you have in lesson 1, there's a different way to create your grid. And now we're going to click the button again. This time we're going to use the external polygon layer. And this one is project domain. Well, it's alphabetical, so just hit the P key on your keyboard and it'll take you right to it, and then hit enter. The cell size field will be called cell size, and that has a 30 in it, not a 100. And then if you want, you can align it to your elevation raster. I'm not going to bother doing that, but it is a feature that we've made. I'm going to click OK, and this is going to overwrite the grid and reset the computational domain to this polygon. You can only have one polygon per computational domain. And I'll click OK. There were now 54,000 cells, and we're kind of done with that. So I guess I could just uncheck it. And you can see here that grid element number 1 is now right here. And if I click on those, I don't know. Oops, sorry. And you can see that my cell size is now 30. All right, let's go ahead and move on. Let's go ahead and see what the next step is. So the next step is to save the project. So it's always good to save after you've created a grid, because then if you messed up the project or something, you wouldn't lose that much. So you can save it, assign the grid elevation. Well, let's just save it. It takes a few steps. So you click the save icon right here, and then you have to navigate, because it kind of forgets where you were. So you have to navigate back to your location. And that's why I tell you to put this in quick access, because that happens a lot in QGIS. You have to navigate back to the location that you're looking for. And again, we're just going to call this lesson 1. And I just hit enter and it automatically saved it. And then I just want to show you that this is my lesson 1 QGZ file. A QGZ file is sort of like an ArcGIS MXD file. It stores all of your layers and how they're grouped and how they're colored and kind of information like that about like where they're located. And then this is your geo package, and that kind of just stores your Flow2D files that can be converted to the data system. So this is polygon layers and points layers and tables and polylines and all that stuff all wrapped up in a single package, and very easy to manipulate, like the layer, the layout and all that, but very difficult to break. So that's kind of the beauty of a geo package. All right, I'm going to pull this back off the side, and we will continue on with the next step, which is to assign the grid elevation. So we need a grid elevation raster, which is in the project layer, and we need a widget and a processing tool from the widget. So the grid elevation raster is right here, and I'll pull it onto the map, and you can see that it covers the entire project area plus a bit of a buffer. So yeah, that's important. It needs to cover every grid element, but these things can have holes in them because they can have things filtered out, like buildings or bridges or overpasses can be filtered out of the data. So if they're filtered out, there's an option for that. And if you hear, what I did is I went over to my grid tools widget, and I clicked this first button, sample grid elevation from a raster. I only have one raster in here right now, so it's the first one that it lists. And I'm going to put a -9999, and I'll show you why I'm doing that in just a second. And then I'll just click OK. Now, if you had like missing buildings and things like that, you might want to check fill no data to fill that data in from its neighbors. Okay, it's going to average it from its neighbors. And then I click OK, and it's going to be finished in just a minute. I'm going to click OK again, and now I'm going to turn it off. And what I wanted to show you, the reason we put that -9999 is because the raster warp method that it uses to interpolate the data actually builds a new raster. And so that -9999 just gives you the no data value for the new raster. And if I open that up, you will be able to see that that this raster is kind of special. It is the exact width and height of the grid system, and it has the same pixel size as the grid element. So it is just every single one of the pixels in here is an average of the original data, which is a 1 foot by 1 foot pixel, and this one is a 30 foot by 30 foot pixel. I'm going to remove this layer because I don't want, sometimes you have to recalculate your elevation, and I don't want to lock that layer by having it loaded in my map. I'm done with this one, so I can turn it off. And the next step is this just tells you where you can get more information about the interpolation. And I'm going to now assign roughness data to the grid. And same thing, will be loading the data just by dragging it, dropping it onto the map, and then using the widget to run the process. The process will be a point sample of the polygon layer, and it will take, and I'll show you how it works as soon as we get in there. You have a choice. You can do an area average or a point sample. And then we'll look at the data that we just created. So I'll minimize this, drag my data back over here. And here we have our Manning's roughness data. And back on this, I can use this button, and we want to choose the Manning's roughness layer. It's our only polygon layer with roughness data in it. It only has one field, which is roughness. And I want to do a centroid point sample because it's faster. An area average will be more accurate, and a point sample will be faster. So click OK. Let it finish its job. And then I want to show you what this data looks like compared to the grid. So I'm going to move it down a few layers. First, I want to just put it down here for a second, open the schema layers, and I want to put this just underneath the grid so that we can zoom in on one of these. And for grid element 1, or 2, yeah, it's grid element 1. Let's see, for grid element 1, we have a point sample. So it's going to find the centroid of the grid element. Let me select it so that you can maybe see it a little better. Okay, that didn't really help. So this is the one I've selected, grid element 1, and it takes a point sample of the centroid. Let me turn this off. There we go. Say a point sample from the centroid, and it picks up the end value from this polygon right. I'm gonna select it right here. So this one would take the sample from this polygon, and this one would take the sample from this polygon, because I'm just clicking the very center of that cell. That's how I'm selecting that polygon, and that's how it chooses it. Now, if you do an area weighted average, it's a little bit different. It's going to intersect the polygon to the grid, and it'll be, in this case, it'll be a series of parts. It'll be this part, this part, this part, and maybe just a tiny little slice of this guy, area weighted average, and apply a single roughness. So it's like a bit of a process. Now I'm going to bring this back up here because I want to show you something different later, but we are finished with it. So I will, I turned it off, and then I selected the comp domain, and I clicked this button, which is zoom to layer. Okay, let's go back here now. Oh no, the next thing it wanted us to do, sorry, was to review the grid element data. So if I right click the grid layer, I can click Open Attribute Table. And remember, the grid layer is in your schematic layers because it's finished data. The user layers is not finished data. It's data that you can manipulate. And the schema layers is finished Flow2D ready data. So what you get in the grid layer, and by the way, don't open this table if you have more than, say, 500,000, 2, 3, 4, 500,000 cells. Don't open this table because it might really take a long time to load. So instead, use filters. But you see, you got it. End value, single end value for every cell, single elevation for every cell, and then this stuff can be loaded later after the run is complete. And I'll close that up. And if you wanted to find a cell quickly, you could put it in here. Let's say 5,000, and click the tool. Not only will it zoom you right to it, but it will also highlight it. Okay, I'm going to close that up. That works the other way too. If you click this guy and then you just click on a cell, it will, sorry, the problem is that I lost it. It will select that cell. It doesn't highlight it. Unfortunately, it doesn't highlight it, but it'll select it and load all of its data. And you can also render the elevation. So you can see your grid element elevation right here through the render. Okay, so I am going to shut that back down. And let's take a look. I think the last thing to do is to set up the control variables. And you do have a variable description in your data input manual. So if you're looking for the manuals for Flow2D, it's back in Flow2D Pro documentation, Flow Help manuals, and this is the data input manual. It's kind of like the most important manual for Flow2D. All right, let me get back to where I was. And I'll move this out of the way. So what we are going to do is set up these control variables on the control variable side and then the numerical stability side. And then we will save it, save the project, and then export the data. Okay, so let's go ahead and do that now. We go here, click the button. It's a 24-hour simulation time because it's such a small project. It doesn't really need any time to drain. So 24 hours is fine, but projects are typically more than 24 hours. I mean, 36, 48, 100 and some, it always goes by hours. Output interval for this one is 0.1 because again, it's a small project with a small simulation time. So I can give it a fairly good output interval with good output data. I'm not going to change this to detailed graphics because I mean, it just runs faster in screen mode, so I don't bother with that. I'm going to set the limiting fruit to 0.9. That doesn't mean that we are limiting our model from becoming supercritical. The model can still go supercritical. What this means is that if the model, we know that this is a super flat project area. And so it's not very likely that this model, that this project is going to go supercritical. So what I'm telling it is that it's stay subcritical. And if perhaps a grid element is calculated supercritical, let's do a minor n value adjustment automatically to keep it subcritical. I'm also going to put in a depressed depth variable, because if you have a grid element that is 3 feet lower than all of its surrounding neighbors, it can cause you problems. So we want to check and make sure that the water can move and we don't have some ridiculously depressed cell. Now let's go over to the numerical stability side. The only thing we need to change here is this one. The Flood Control District of Maricopa County runs this 0.004, but I like to run 0.01. This is a automatic surface detention of 0.01 feet. What this means is that the water that runs or that hits the cell is going to need to fill up to 0.01 feet before it starts to exchange with its neighbors. It's sort of like an initial abstraction, but it's really more of a physical property, because this prevents the model from having numerical surging. So if you keep it at 0.004, then you got to go fix a bunch of numerical surging. If you leave it at 0.01, you don't have to deal with that numerical surging, but you might lose a little bit of rainfall at like initial abstraction. But maybe you can add it back into your rainfall so it wouldn't even matter. If you have a Courant number for this project, I'm just going to leave it at 0.6. So basically, this is another numerical stability control that controls flow-2D variable time step. So if a grid element while it's flooding, if a grid element calculates a Courant number that exceeds 0.6, the model will throw out that data set, rerun it at a smaller time step, and until it no longer exceeds that stability criteria. So 0.6 is kind of your default starting point. And then if you see that you're having quite a bit of numerical instability, you can start bringing that down a little bit or making like local changes to some of the cells that might be causing problems. That's all in videos later on that Jim does on numerical stability and volume conservation. And they're all on the website. You can get to those videos for free on the website through the training packages. All right, the next thing to do is to use this button here to export the data. So I'm going to call the button, and then I want to export my data to this location, to this project. So click select folder. We don't have any rainfall yet, so for this one, we'll just uncheck that and then click OK. And these are the 4 files that it exported. And if I come over here, I can see these guys right here. And again, these files are set up with just ASCII data with lists of variables. So if you want to see what one of these variables is, you go to the cont.dat tab of the Flow2D data input manual. So that's your control variables. This is roughness variable, grid element number on the left, roughness on the right. This is the tolerance file, and this is the X coordinate, Y coordinate, X elevation of the grid. So this is X coordinate of cell 1, Y coordinate of centroid of cell 1, and the elevation of cell 1, and down all the way to cell number N, which is like 54,000 of them. And now we can run it, but again, there's no water in there. So even if I run it, it's not going to do anything. So if I click this guy, that's the run Flow2D button. You'll probably, the first time you click that button, you'll probably need to set this variable. So you'll click the path, and Flow2D goes into C drive, program files x86, Flow2D Pro. That's also in the document, so don't worry about trying to remember that. And then your lesson 1 export is usually set when you export that data for the first time, and just click OK. If you don't see this, you're probably running in the free version. That's okay. This should still run in the free version. If it doesn't, contact us. You need to do build 21 to get it to run in the free version. And we don't really care. It doesn't have to finish because, like I said, there's no water in it. We just wanted to make sure that it could run. I'm going to close it out, and I'm going to check one thing. Back in the data, there should be a file called summary.out right here. And I'm going to go ahead and open summary.out in Notepad. So Notepad, because it's ASCII data, go all the way to the bottom, and I'm just looking to see that that says grid element size 30, and then that's also accurate. So that's what I want to see. Okay, minimize that, and let me just come back here and make sure I did everything. So export the data. Yep, unchecked that. We looked at the data files, then we ran the model, and that is finished. So this is the end of the video for lesson 1, part 1. We'll continue on with the next video for lesson 1, part 2, and that video should go right around in here somewhere.